Hi, my name is Steve Rahi. I am a premier field engineer specializing in management technologies. Today's discussion is part 2 of a series focusing on caching in Configuration Manager Current Branch. Just looking at some of the different options. Part 2 is again focused on pure caching. Just talked about pure caching in part 1. This time we're going to use this session to talk about pure caching specifically in OSD scenarios. Now, specifically, here's our agenda, but before we get into this, again, part 1 talked about pure caching in general. Here we're going to focus on OSD. This agenda, and what you'll find if you have already been in session 1, is that much of this initial part will be similar to what you've already heard, but we will quickly turn and focus on OSD. The demos will very much focus on OSD. So, also, there's several moving parts for configuring and using caching in an OSD environment. The goal of this session is to walk you through those configuration options, show what they are, show them working, but also to acknowledge that the way you implement them as you use OSD and pure caching may be different, right? So the goal is for me to show you all of them and show you how all of them work, and then you can choose which ones you want to bring to bear. So in terms of the agenda, what is caching in general? We'll talk about that. What is ConfigMgr pure caching and OSD specifically, and why do we care? What are the requirements for ConfigMgr pure caching and OSD, and then the components that are required for ConfigMgr pure caching and OSD. Finally, talk about a couple of scenarios and how it works, show you some demos of pure caching and OSD, see that happen in action, wrap up with a few tips and tricks, and we'll close out the session. All right. So what is caching? This is not a config manager specific discussion. I'll probably weave a few config manager things in here as we go. But in general, what is caching? So whether we're talking about branch cache or peer cache or delivery optimization or third-party caching products, caching is, or even when we're talking about not even config manager in the picture, caching is a mechanism that will help optimize network usage. It is intended to provide a solution to leverage local content source peers for acquiring the content, right? So we talked about in part 1, that's just general content acquisition. Part 2, this is OSD, so it could be Pixie Boot, different things that are required for OSD, and so forth. Could be even non-config manager stuff, because again, we're just talking about caching in general, right? Caching, in order for caching to work, you need to be able to define your peers. What systems can share content with each other? Again, not a config manager discussion per se here, right? So there has to be a mechanism to group these systems that will share content with each other. A very commonly used mechanism is the subnet that clients are on. So there will be peers or could be peers on a given subnet that systems could leverage to retrieve content if that peer on the same subnet has that content already. In the config manager world specifically, you'll see this more in a minute, we add boundary group to that mix, and so that boundary group defines the group of systems that could be sharing content back and forth, right? And then flipping back to subnet for a minute, even inside the boundary group, there's the ability to set to only share content with systems that are on the same subnet. Again, you'll see that in a minute, not to dig too far into the config manager stuff just yet. And then finally, what is caching? It's a way to enable a reduced infrastructure. In config manager, that means fewer distribution points that you need to set up and maintain. Now turning to config manager, right? Even on the previous slide, I couldn't help but talk about config manager a little bit. So here in config manager, specifically, potential peers that can share content with one another are defined first by boundary group membership. So if machines are in the same boundary group, then they could share content with each other. There is a specific setting on the boundary group, we'll show this to you in just a minute, where you can define that even if machines are in the same boundary group, only let machines that are on the same subnet within that boundary group share content with each other, okay? So pure caching is a capability native to config manager, meaning you can take advantage of it in any supported configuration that config manager exists. If you want to, just have to turn it on. And in config manager specifically, Peer caching supports all content lookup scenarios, includes OSD, which is what we'll be talking about in this session. So why? Why do we care about ConfigMgr peer caching in general, but then why do we care about it with OSD? So the first reason is, and put in all caps there, it is native to the product. There is no additional cost associated with using peer caching in ConfigMgr. Right? There may be a significant additional cost when using third-party caching solutions. So being aware of this capability, native in ConfigMgr, how it works, and where it can maybe save you money, help your operations, really important. The ability to reduce your infrastructure footprint. Again, used to be that because of network conditions and network layout and so on, organizations would have to put out lots and lots of distribution points, whether those are traditional distribution points, pull distribution points, whatever. Here, we can reduce the number of distribution points that need to be placed and maintained and still have local access to content through peer caching. Right? Reducing network traffic is a big one. So you can respect the slower WAN links maybe that are out there, or even the big WAN links are out there that you don't want to saturate with ConfigMgr traffic. And then fourthly, the ability to decrease content download times. If you're on the same network segment with a peer, you can likely pull that content much faster than going over a WAN link, again, depending on speed. So what are the requirements for ConfigMgr peer caching and OSD? Right? Well, some of these, first three, are requirements of peer caching in general. First is that your super peers must be domain joined systems. So super peers is a label that you will see in the logs referring to systems that are hosting content being shared to others. Another way that I sometimes refer to these systems is a content source peer. Right? So either way, if I say either one, I'm referring to the same type of system. A machine that has content that is able to share that content with others in its boundary group or on its same subnet within a boundary group, depending on configurations. All right. Now, the super peers, the content source peers, must be domain joined machines. That does not mean that the machines that receive the content from the super peers are domain joined. A great example of that, specifically in the OSD scenario, are systems that are building and during the Windows PE phase. During the Windows PE phase, those systems are not domain joined. They are the equivalent of workgroup joined, right? But in Windows PE, we can easily pull content from a super peer or content source peer, no problem, right? So that's a great example of that difference, right? Boundary groups. So we do need boundary groups. I've mentioned this a couple of times already. A boundary group defines what systems can be potentially sharing content back and forth with each other. And you can further refine that by, in a boundary group, saying within this group, only let machines that are on the same subnet share content with each other. Again, I'll show that to you in just a minute. You do need a ConfigMgr client. And that ConfigMgr client can be on any supported OS. It doesn't need to be Windows 10, doesn't need to be a server, just needs to be a supported operating system. And then fourthly, specifically for OSD scenarios, you do need a network access account. That's only required in specific scenarios, so it is required when a task sequence is started from Software Center, then has to reboot to a boot image. During that boot image process, during the Windows PE phase, the network access account is used to authenticate download requests from peers. This is not a high rights account. It just needs to have normal domain user permissions to be able to access those peers and pull content, right? But we do need to have some sort of authentication mechanism while in Windows PE. Okay? So what are the components of ConfigMgr peer caching? Just want to do a high-level overview. We talked about the first three already: boundary groups, content source peers, super peers, network access account. But specifically, there are a few concepts and terms that you will see in the documentation, and sometimes they might be confusing. They'll be used in conjunction talking about various ways that you can leverage OSD. So I want to go over those here. Right? We'll just the idea of seeding a super peer. So it's very possible that in an OSD scenario, you will have a task sequence that you need to deploy out to the environment, and you may not want that task sequence to run on the super peers. However, you do want the content for that task sequence to be available in the super peer. So there's really three things we'll talk about under here. The first is this task sequence step known as download package content. You'll see this used in several of the demos coming up to really try to illustrate how it's used. So this is an available step. You can use it. Typically, the download package content step is used as part of the upgrade operating system type task sequences. It is not required to be used there. Can work with any task sequence. Knowing how it works is really important. So basically, the download package content step is used to define content that should be downloaded as part of, or even before, in some cases, the task sequence begins. So this step alone could be used to seed a super peer to enable it to provide content to imaging systems. It doesn't support all content types, specifically doesn't support application content, but up to you. It's a tool in the tool belt. You can even have multiple download package content steps and execute which one you want by conditionals if you want to, right? This step, the download package content step, is absolutely not a requirement for task sequences to leverage a peer for retrieving content. But if a super peer is using, if you're using this to seed the content onto a super peer, likely when this task runs, it will need to go to a traditional distribution point first to get the content. But then from there, if we use this to seed the content, that super peer will then be able to serve up content to others within the same boundary group or within the same subnet within a boundary group, right? The next one, pre-download content for this task sequence. This is a step or an option, if you will, that you can configure on the deployment specifically of a task sequence. So what this does is it will evaluate a task sequence as soon as it arrives and begin downloading required content. So this one's interesting because prior to this, the only way that we would get content downloaded beforehand is if a given deployment were required, right? And this discussion does not just apply to task sequencing. It applies in general. So let's go outside of a task sequence example. If we deployed an application or a package, and that application or package was set to available, then no content is downloaded for that application or package. But if the application or package is set as required, even a year out, right, then we will immediately start to download that content. That's just the way that ConfigMgr is designed. Same thing is true for task sequencing, except now we have this pre-download content for this task sequence, which means as soon as the policy arrives for a given task sequence, then we will look, with this option enabled, we will look inside the task sequence and begin to download any content. So there's two ways to think of using the pre-download option. Again, this is kind of was designed for and thought of and documented actually to be used with upgrade task sequences, right? So, and I'll talk about that just a little bit. We're not going to go really in depth on it, but when pre-download is enabled for an upgrade task sequence, the client will evaluate and respect any conditions that are defined on the upgrade operating system step itself, right? So let me be clear. That doesn't mean that the pre-download option will evaluate and look at all the conditions for every kind of step inside the task sequence. It's only specifically if there is an upgrade task sequence step. The reason that's important is when you have an upgrade scenario, you may want to have a single upgrade task sequence that spans all the different platforms that you might have, languages, architectures, whatever. And so by the fact that the pre-download option will look inside of the upgrade task sequence or upgrade operating system step to determine what are the conditions, what do I need to process through. That way you can have multiple upgrade operating system steps and define them for different languages, x86, x64, whatever, but only download that chunk you need. Okay? So the create OS upgrade package then, in that scenario, would need to be created with architecture and language defined so that we can then respect that. Let me say it again. In order for all of this to stream together, here we're just kind of on a tangent talking about an upgrade scenario, where the pre-download works with the upgrade operating system step, you would also then need to define the architecture and the language when you create your OS upgrade package. I'm not showing you this in this demo or in this session because this is really outside the scope of this, but I mention this only to illustrate one usage of the pre-download stuff, and that is in the upgrade task sequence. What about non-upgrade task sequences? Well, here it works too, right? We're going if we have a task sequence deployed with the pre-download option set, then when that non-upgrade task sequence shows up, the client will evaluate all of the content referenced by the task sequence and begin to download it. Now, what this means is you may have some steps in that task sequence that we can't evaluate, and we don't know what that content is yet, such as if you're using applied device drivers. These are dynamic steps, and so we would need to wait for the task sequence to execute before we actually know what content is needed. Right? No conditions are evaluated to control download outside of that one step we just mentioned, the upgrade operating system. So if you have multiple, as an example, applied driver package steps, and you decide which one to execute based on conditions, and each one defines a driver package, if you have the pre-download option, we're going to download all of those into the cache because we don't look at the conditionals there, right? So I mentioned all of that to say, pre-downloading is helpful in some circumstances and will itself take advantage of peer caching whenever it needs to pull content, right? Can very easily be used in our discussion to seed the super peer, but know what it does, right? It is absolutely not a requirement to set the pre-download option in order for peer cache to work, but it can be very useful in seeding the super peer, right? Okay. So, and let me just say here too, the pre-download option is awesome that we have that now, but this is something that customers have grappled with task sequencing, with imaging for a long time. Even before the pre-download step was available, customers would engineer their task sequences such that they could effectively pre-download the content. Some of the partner products that we have for caching, 1E, Nomad, and Adaptiva, there's customers that have built into their task sequence basically a fail step at the beginning of the task sequence because they want to push these task sequences out to their caching-enabled systems with 1E Nomad and Adaptiva and have those systems cache the content, but not run the task sequence, right? And that's very doable. Or even just have other systems, right? There's so many scenarios for it. It's silly, right? But just suffice it to say, this could be done even before the introduction of the pre-download content step on the task sequence. All right. So we'll see that work in a little bit in the demos. So in the task sequence world itself, right? So we are on the topic of seeding the super peer. So kind of pulling together what I just said. Task sequence. All image deployment is handled through the task sequence. It is fully possible to design your task sequence such that it cannot be executed in certain scenarios. So if you want to run a task sequence on a super peer for the sole purpose of seeding that content onto the super peer, that's great. That can be done easily. Just engineer the task sequence so that it will detect that the system is a super peer and fail out. And I'll show you an example of that as we go along. And again, that also is not a requirement for the task sequence to leverage a peer for retrieving content. I'm weaving these in because all of these concepts kind of work together, and you'll see them documented in various ways, just trying to shed the light on what these things actually do and talk about how they could be used to support your super peer scenario. Then finally, task sequence variables. So the task sequence variables, SMSTS peer download, SMSTS preserve content, SMSTS peer request port. The first two, actually the first one, is required to enable the task sequence to look for a peer as a download source. The second one is a flag to tell an imaging system hey, you've gone through the work of retrieving all this content. Why don't you just preserve that content in your client cache after you're done imaging, and then maybe you can be turned on as a super peer yourself and be able to serve that content for others, right? So that's what the SMSTS preserve content does. And then the SMSTS peer request port. There is a port defined by default on clients that you will talk back and forth on to retrieve content. This just allows you to alter that port if you need to and specify a different one. And again, you'll see all of this again. But these are just an introduction to some terms and concepts and so on as we start to work our way toward demo. Okay, so ConfigMgr peer caching and OSD, some scenarios, how it works, right? So two big umbrella buckets of ways that you can leverage peer cache. One is for imaging and one is for standard deployment. So for standard deployments, we've already talked about that in part one of this series, so I won't talk about that again. Here we're focused on OSD, imaging, right? So here we talk about, again, kind of two subcomponents of imaging. One will be the standard imaging process, leveraging peer cache enabled systems, super peers, to retrieve the content, and then also the idea of pre-staging the content onto your content source peers, super peers, so that imaging systems can leverage it. We'll talk about that. Now, in order for peer caching to work and to be factored in at a higher priority than traditional DPs, we've got to have a selection criteria, a selection order, if you will, to establish priority. And this is what it is. So if we have a client on a distribution point, we're going to use that distribution point because that distribution point is local to us. Beyond that, again, I mentioned that we will use our boundary groups as a way to define our super peers or content source peers we can talk with. But within that boundary group, we can opt to only allow devices that are on the same subnet to use a peer on that same subnet. That's this next selection criteria. So if there's a peer in the same subnet that has the content, we'll use that. Then we'll use a DP that's in the same subnet. Then we'll expand out. If there's a peer in the same boundary group, we'll use that, and then use a DP. And then we start rolling down to neighbor boundary groups, fallback scenarios, all the way down through Cloud DP. So these two scenarios in the middle define your boundary group configuration necessary and define where you can use peers, but it's only in these two scenarios within a boundary group, right? Okay. So I want to do a couple of demos. First will be configuring ConfigMgr peer cache and with an eye towards specifically OSD. So to talk about that, let me pull in the lab, and it's here. And you see some task sequences that I have set up for demo a little bit later. Let me go into hierarchy configuration and specifically look at our boundary groups. So again, ConfigMgr peer caching leverages boundary groups to decide which clients are peers of one another. So make sure your boundary group contains at least one content source peer. I just have one boundary group, so it's not a problem. But if you have multiple, make sure that your boundary groups contain at least one content source peer or multiple, depending on configuration. Right? Ensure your boundary groups are configured properly. So this is really an up-to-you kind of thing, and it can vary depending on your needs. There are some situations where you have lots and lots of boundary groups that really clearly define the network configuration. Consider whether you need to be that granular. Maybe you do, right? Again, we're talking about peer caching, so factor in your needs beyond peer caching for boundary groups. But there could be scenarios where maybe an organization runs today without boundaries and needs to establish boundaries just to support peer caching. So you can actually make really broad general boundary groups, if you will, and then inside that boundary group turn on only talking to systems on the same subnet, so you get the granularity that you need for peer caching, right? It's up to you. So let me show you. So I have my boundary group here. So if I go to properties on it, then pretty easy. Here's my boundary. Here's my distribution point and remote distribution point. And then I don't really have any relationships here, but here's the option I was referring to. So you can tell ConfigMgr by default, hey, allow peer downloads in this boundary group. So any machine in the boundary group that has a content source peer in the same boundary group can pull content from that machine. Or you can be even more granular and set this option here that says, hey, even though I'm in the same boundary group with multiple content source peers, I only want to use the one or two that are on my same subnet, right? So you can configure this however you need to. All right, so let me close that for a moment. And just another word about super peers. So the boundaries, boundary groups and boundaries help define where those super peers are or who they are, and then machines can use them to acquire content. But before the machines can use them to pull content locally, those super peers need to have the content so they can serve it to others, right? So plan for a strategy that will provide the content to those super peers so they can serve it to others. There's a couple of thoughts here. You'll see both of them shortly. One, seed the super peers with the content. We've talked about that already. There's a way that you can actually deploy task sequences, deploy content to these super peers and get the content there, but protect those super peers from actually running the task sequence and actually imaging, because you may not want that, right? That's one option to proactively do that. Or another way would be to plan that any system actually being imaged in certain conditions should itself become a super peer and begin to have a way to serve that content to others within its subnet or within its boundary group. Either way, fine, there may be some shades of gray within those or other ways to mix them up, but those are the two big broad categories. However you do it, one thing you also have to consider is fallback, right? So what I mean by fallback is your super peers, in order to be able to share content with others, they must themselves be able to acquire the content. If the super peer is in a boundary group where no distribution points are defined, then this super peer is, by that nature, in a fallback relationship to available distribution points. So that means if the deployment going to these super peers is not enabled to allow fallback to the distribution point, those super peers can never be provisioned with content, right? So you need to factor that in and realize where your super peers are in relation to distribution points, allow for fallback as needed. And the good news here is with our selection criteria, let me just pull the lab out for just a minute and go back to our selection criteria just a sec. So with our selection criteria, you can enable deployment for fallback, and we will always prefer the peer in the same subnet or the same boundary group, and only go to the distribution point if we can't find a peer. So it's not necessary that you would create multiple deployments, some enabled for fallback, some not, but just know that you need to consider fallback and understand then the selection criteria and priorities so that whenever you do that, it all kind of fits together. It may sound more complicated than it really is, but just some things that you do need to consider as you're planning for this. Okay, so back to our demo. So that was setting up boundary groups, right? Now that we have boundary groups configured, we need to actually go enable the ability for a system or systems to act as super peers. So what I've done, I just have a really simple lab. So I've turned on one system as a super peer. So the way I did that is I configured custom client settings and specifically enabled the system for being able to serve content. So enable ConfigMgr client in full OS to share content. Yes, here are the default ports, right? Again, you probably don't need to change those, but you might need to change those. So while you're enabling peer caching, so here's some things to think about. Before you do this, figure out your strategy for identifying which systems should be configured as super peers, as content source peers. Should it be all or most systems? Should it be limited or targeted systems, right? Should it be that all of the systems that are imaging should in themselves become super peers after they're on, right? Another thing to think about, super peers should probably be those ones that are in the office most of the time, maybe ones that are never powered off, right? So in OSD, you might be imaging in the evening, right, off hours, so your super peers would preferentially be those systems that are never powered off and are always on-prem, right? Another thing that's not directly related to enabling the superpeer, but is indirectly related to enabling the superpeer, is identifying the cache size. So by inference, whenever you enable a machine to be a superpeer, that means that it will be serving content to others. Content that it may consume itself and deploy, or content that it just may host on behalf of being able to serve it to others, and it itself may never actually run those deployments. So your cache size may need to be bumped up, right? Because you want the superpeers to hold onto the content longer. So here's the option at the same time to manage the cache size, right? With these two, I've bumped up mine to 10 gigs, whatever you want for yours. And this also may be a criteria when building your collections to identify your superpeers, because when you build your client settings, these client settings have to be deployed to a collection in order for them to take effect. So I have a collection here called enable superpeers. So if I go to my collections, and here you'll see that I have enable superpeers. I have one machine in it, and this happens to be a Windows 7 machine, chosen on purpose just to show that Windows 7 can serve content just as well as Windows 10. Right? The only thing you have to think about maybe on a superpeer is that server-based superpeers will be able to have more connections to them than a workstation-based superpeer, and so on, right? I don't recall, as I'm thinking through this, whether Windows 7 and Windows 10 have different limits of connections that they can take inbound, so that might also be a factor. But however you do it, right, you will need to define a collection of who your superpeers will be. Now, when you define the collection, you define what type of membership rule. I just chose a direct membership rule because my lab is very simple. Maybe a direct membership rule makes sense because you have a finite number of systems and it's pretty easy to manage. More likely, a query-based collection membership rule will make sense because with query-based, you can take into account different configurations of systems that you want to become superpeers, such as processors that are there, such as, and primarily probably disk space, such as OS version or hardware model or those kind of things. And then it just dynamically updates as systems are added, removed, conditions change, whatever the case may be, right? All right. So now we talked about adjusting the cache size in client settings, right? That is applicable for adjusting the cache size on systems that you are targeting right now to be superpeers. We also mentioned already the idea that in OSD you might want to image a system, and as a part of imaging, then enable that system to be a superpeer later. You can't really do that so much during the tasking, which there's no tasking step to say enable as a superpeer, right? But what you can do is plan for that system to be enabled as a superpeer. So we talked about adjusting the cache size in client settings. Whenever you deploy the client as part of imaging in the setup windows and ConfigMgr step, you do have the ability to set SMS cache size at that time. So configure it, if you anticipate that system will be a superpeer, configure it to match whatever you want it to be in client settings, right, at the time. Just, again, a consideration. If you don't do that, and that system becomes a superpeer, and you've adjusted the cache size settings in client settings, then those settings will come down, no problem. But just an additional configuration option. All right, now, we have a couple of systems that are actually configured to be superpeers. So let me pull in my one that is configured to be a superpeer now, and then we will look at a way to confirm that the system is a superpeer. So here's my Windows 7 machine. Apologies for the screen resolution, but let's look real quick and confirm that this system is a superpeer. It is in the collection. I have deployed policy to it. So if I go into WMI and look at a specific key, policy machine actual config, right, and enum class is on it, and then recursive. All right, and scroll down to CCM underscore superpeer config. Right here, superpeer client config, look at instances, here it is, and then show moff, I will see can be superpeer configured to true. Here's my broadcast port. Here's my HTTP port, right? I'll scroll on down. Here is my adjusted cache size from client settings. Here's how much percent is the max cache size, and so on, right? So this system is, in fact, configured for being a super peer. And you can check that, you know, and just validate if you're having any troubleshooting concerns or you have any questions, or as you'll see in just a minute, you want to detect that the system is a super peer and avoid running the task sequence on it because you don't want the super peer to image, but you do want to see the content, right? So I'll show you that in a minute. So this is all configuring, right? So we've talked about boundaries and boundary groups. We've talked about setting up client settings for this. Now let's talk about another piece that is needed to support the idea of using a super peer during imaging. And specifically, there's a couple of variables that we need to introduce that will enable super peer to be used and other scenarios. Let's kind of talk through. So I have some collections here. Now, there's multiple ways to define variables. The documentation talks about using collection variables. That is not strictly required, but I'll use the collection variables here because it's very convenient, and in an imaging scenario, it probably makes a lot of sense. But you could put these on machine variables. You could put these in the task sequence themselves. As long as the variable's there, you'll actually see me use a variable in a task sequence here in a minute to counteract one of the variables I have set here. Anyway, we'll talk more about that later. But so you have the ability to use variables with unknown computers to enable super peer to be used for content source. You also can use just a regular collection for known computers to enable these variables. Doesn't really matter, whichever scenario you want to use known or unknown, setting the variables accordingly is important so machines know how to proceed and that they're able to use super peers to retrieve content. So I'll start here. I'm not going to use a known computer in the demos, but I'll show you anyway that I have variables assigned here. So there are three variables. There's SMSTS peer download set to true. So the SMS peer download set to true enables the client to use peer caching. So the idea is you would deploy a task sequence to clients in the TS demo collection. When the client runs the task sequence, they are going to retrieve they'll retrieve the collection variable ahead of time or at the time they run it, depending on bare metal or reimage kind of scenarios. And it will be set to true to say, hey, when you run this task sequence, use or feel free to use super peers, local content source peers, to retrieve your content. The second one, SMSTS preserve content, really doesn't have anything at all to do with enabling the system to use a content source peer to retrieve content. What instead this does is it flags that the content in this current task sequence should be retained in the ConfigMgr client cache after deployment, right? So what this is doing is it's setting up a scenario where you might want to purpose this imaged system to itself be a super peer after imaging, right? So you don't have to do that at all, okay? I'll show you a system in a minute that actually doesn't have this set and works just fine in terms of using a super peer to retrieve the content, right? So this is just to enable one to be a super peer if you so desire after the image is complete. And then there's a third one here that I don't have listed called SMSTS peer request port. And this allows you to change the default port number if you want to. If you're using the default settings, then you don't have to use this at all, not required at all to set that up, okay? Now, still in mind with configuring and preparing, right? So let's go to the task sequence for a minute. So in our task sequences, I'm going to use a different one than this. I'm just going to go into an empty task sequence. Right? Doesn't really matter what this is because I just want to show you the step, right? So here is a step to, where is it? Yeah, download package content. This is the step available in any task sequence. And this step is a completely 100% optional step, right? You see it talked about in our documentation, and it's almost assumed that you'll use this. It is not a required step. It is useful in certain scenarios for sure, but determine whether you need it as we continue to go through. You'll see scenarios with it. So this step is used to define which content should be pre-staged onto a client targeted by a task sequence, right? So this step, when the task sequence runs, will download the content that's defined in this step. It's also used with the pre-download option in the task sequence deployment. You'll see all this together, so I'll show you demos of that. So this does not support all content types. Specifically, it will support downloading OS images, OS upgrade packages, driver packages, packages themselves, and boot images. Right? All right. So whenever you have this step in a task sequence, the client actually does not have to install the image or even run the task sequence that's being deployed. There is a piece that will, again, pair alongside of this called pre-download. That's part of a task sequence deployment. When you use pre-download, it actually will look inside of a task sequence and see what content is defined by the download package content step and proactively begin to deploy it. Again, you'll see this. Whether that deployment is available or required doesn't matter. Whether that task sequence deployment is ever run on the machine doesn't matter. It will start to pre-download it. Okay? So focusing back on the download package content. So let me show you, actually I shouldn't have left that. Let me show you this again. So whenever you use, let me actually snap in the download package content this time. Whenever you use this step, you can define the content. So this will show you all the different content types that are in your environment that I just talked to you about. But then there's options. Store in the task sequence working directory. Store in the ConfigMgr client cache. So part of the demos I'll show you in a minute is that you can use this step in Windows PE and have that content translate forward to the running OS at the end after you get done imaging, so that you can, if you make the machine a super peer, start to serve that content up to others, or you can use it in the running OS, which is why you have both of these options, task sequence working directory or ConfigMgr client cache. Just be careful, because if you specify ConfigMgr client cache, when you are not in a running OS, the task sequence will fail because there is no CCM cache yet. The client has not been installed. Okay. So now, again, all this to talk about options to get ready. And again, you don't have to use all of these. I'm trying to walk through what's available, help you understand what's available, and then you can make use of what you want to make use of. And you'll see a lot of those in these demos that I have coming up in different configurations, right? So let's continue on the pre-download option for just a minute. So this again works in conjunction with the download package content step. So after seeding of the content peers, back up from that statement. So yeah, this works in conjunction with the download package content step, and specifically in OSD, this will allow you to seed content source peers with content, and you never have to run the task sequence on them. And I should say also, you'll see this, you can actually get, as we already talked about, the content seeded onto a super peer without even using the download package content step. So it's an option for you, right? If you want to seed the content onto a system using this step, using another approach, and you want to make sure that that system itself does not execute the task sequence, then great, engineer the task sequence so that you avoid having that step executed. All right, so let me pull the lab out just for a minute, and then we're going to start getting into the details. So here's just a diagram before we kind of dive into the demos of how all of this works, right? So you saw this diagram in part one. I've redone it a bit to try to illustrate imaging. So here we'll just assume that this is the first imaging system that is going to receive the content. So this diagram definitely does not cover all the scenarios. It just tries to illustrate the flow a bit. So let's assume this is going to be your first machine in a boundary group or a subnet within a boundary group to actually image, and that this machine will itself become a super peer as a part of imaging. So this machine will request the content. The management point returns the content locations. There is no super peer yet seeded with the content, so this one will need to download from a distribution point directly. So the content is retrieved from an available distribution point. the content is cached on this machine, which is going to ultimately be a content source peer. And then the task sequence is configured to download the package content, and variables are there to configure that it will persist and preserve the downloaded content in the client cache after the task sequence completes. And the task sequence is configured to add the image system into a collection so that it receives the options to become itself a super peer. Okay? Now, the next system, one of these over here, asks for the content because it's going to start through the task sequence. Now, the management point returns the content locations. Here, the response includes the distribution points and this content source peer. So the client is going to choose preferentially the content source peer, retrieve the content, and start to image. Okay? All right. So the best way to show this is to do a couple of demos. Okay, so I've shown you this already. I'm just going to try to show it to you again to help with clarity. So again, I have my collections. I have this collection, which I'm not going to use at all for known computers, where I have defined my task sequence variables to enable retrieving content from a super peer and also enable this system itself preserving the content in plans for it to perhaps be a super peer. I'm not using any known computer deployment, so I also configured these collection variables on my all unknown computers collection. So my unknown computers, when they image, will have access to these variables as well. I did not configure the port variables because I am using the default ports, right? So the variables themselves are absolutely critical to enable the task sequence to do what you want, either to use a super peer or to use a super peer and become a super peer itself, whatever you want to do. So let's go into a couple of demos, right? So I want to show you a couple of options to help you seed the super peer, right? So the pre-download, so let me go over to my software library. So I have these. So here's my seed peer cache, right? So when I deploy this, I do have the option to pre-download, okay? This option is set on the deployment that I use to seed my super peers, okay? So again, this will go into the task sequence and specifically download any content defined by the download package content step. You can optionally run this to seed a super peer without actually executing the deployment, okay? So and as a reminder, the download package content step supports OS images, OS upgrade packages, driver packages, and boot images themselves. So to show you this live, let me pull a device in and I will show you running the task sequence to preload the content. I've actually got it done already, so no problem there. But I do have this task sequence when it comes up set up to seed my peer cache. So this is the one I'm using this time, right? And so I've run it. And so in my content cache on my super peer right here, I have all of the content that I need. So here's a batch file demo that I've got configured. You'll see in a minute. Here's CCM setup. Here's one of my boot images that I downloaded. Here's an install win, the OS. And here is another install win, right? So all of these are in the cache of the super peer. And I got that content there by running the task sequence. Well, let's go look at the task sequence for just a minute. So if I edit this particular one, here's my download package content, and there's 4 here. There's actually 5 on the Windows 7 machine because I got another one of those pieces of content there a different way. But I'm storing 4 of them here, so I just executed this task sequence against that machine, and I'm able to use it now to serve the content. So how do I know that this actually did what I told you and received this without ever running the task sequence, right? So I just realized I said something wrong. Let me clear it up. I published the task sequence to this machine. I've never run it, right? Not that I remember. Let me just make sure, see if I actually ever did run it. I don't think I did, but let me see. System Center, Software Center. See if it'll show me real quick. Either way, the logs are there. So this one, yeah, I've never run this, right? It would say reinstall if I had run it. So, but this is here. And it is an available deployment. It is not a required deployment. So what I did, and this is kind of a time thing whenever you're doing a demo, as soon as this machine received the policy, it immediately started to download the content because I had that pre-download flag set. And so what I needed to do is grab the logs, and here's, actually I did this on 2 machines. I think the better logs that didn't roll over are on the Windows 10 machine. So let me just show you. I'll show you here too, but let me show you on the Windows 10 machine in a minute. So if I go look for, let me see if I can find an entry in here. Download progress. Let's see if I find that. Nope, didn't find it. Let me go to the historical log. It may have rolled out of this. I'll go to the Windows 10 machine because either way, it's the same log entry. Let me just see if I get lucky in my logs here. Okay. So here's the historical log. Let's try that. Nope. So I'm going to go to the Windows 10 machine because I know those saved logs actually have it, but it's the same exact concept. So we pull up the Windows 10 machine here. Put the right password in. Great. My license will expire soon. So same deal. I should have the deployment here, but I don't think I've ever actually executed it on the device. Let's validate. Here comes Software Center. All right, so operating systems. And yeah, I've not installed this one either. So these are logs that I captured right after the machine received the deployment. Let's look at Execution Manager log here. And this is Notepad, so I'll just quickly find an indicator of what's happening. Okay, here we go. So now you'll see download progress received for program batch, right? That's a program that I have. And if I scroll around, you will see enabled for optional pre-download, false. Enabled for optional pre-download should be true here in some of these in just a minute. Let me see if I can find, let's see, just enabled for optional pre-download, false, false, false. Let me find one that, there we go, true. All right, so here's some entries that indicate true, that we're actually going to be able to pre-download the content for this one. And then there's other ones that we would find through here that we would be able to look for, right? So basically this Execution Manager log is showing as soon as I receive the policy for a task sequence where I've enabled to pre-download the content, we'll start to pre-download the content. Then it's in the super peer or in the cache so that if the machine's a super peer, again, doesn't have to be because this one's not, and you see it's here, then we can serve it to other people, right? Okay. Now, the task sequence itself, whenever you build it, you probably want to design it to fail in case the machine is a super peer. Maybe you want to have the task sequence, you deploy the task sequence to a machine that is a super peer, you want to get the content there, but you don't want to actually image the super peer, right? So let's rewind a minute to discussions earlier in this. You do not have to use the download package content step to seed the cache, right? People have been doing this for a long time, just with a required task sequence that has engineered the task sequence to bail out of running if it detects certain conditions, right? So you can go back to that discussion we had earlier about the 3 different configurations where you might want to use different configurations to seed the super peer and apply them to what I'm going to show you. But if I go into the task sequence, first step is I'm going to validate the task sequence execution, right? So in this case, I've actually deployed the task sequence as required. And so every machine that's targeted, including the super peers, will receive the task sequence, will immediately start to download all of the content defined in the task sequence, whether it be content here that it will also download with the pre-download flag on the deployment, or just content that's defined with the apply operating system and the install rich copy and all of those, right? It will see the content in the task sequence, start to deploy it. Now, be aware, there are some steps in a task sequence that don't actually define the content, and so any content that is needed as a result of those steps won't be pre-downloaded. Examples include the default apply drivers section. This is a plug-and-play thing. We don't know what drivers you need until we get to that step in the task sequence, so really not able to pre-download. Another would be dynamic applications or packages, where we just don't know what those are until we are at runtime. So just engineer your task sequence to have the content defined, and then you can deploy it, pre-download it using one of those three options, and it should work fine. Whatever you do, though, you probably want to build in some protection so that this task sequence doesn't actually have an opportunity to execute on your super peers. How do you do that? Well, here's the first step. Validate task sequence execution, right? So if it's a required task sequence, or it's a task sequence that is available or required with the pre-deploy flag set in the deployment, we'll download content differently depending, but we'll at least download content. If this task sequence gets accidentally executed on a machine by a technician sitting there, or by a user, or accidentally set to required when you really didn't want it required, right? You can use the task sequence itself to protect. So the first option will be just a WMI query to say, hey, is this machine a super peer, right? And if this machine is a super peer, then, actually, let me go back into it, okay, so only go into this section if the machine is a super peer, right? So if it's not a super peer, it's going to go directly into imaging. But if it is a super peer, it's going to go right here. And actually, I realized I had my logic backwards. Why did I do that? So I wanted this to be, let me change it. Select, okay, so false. I want to detect that this is false, and then set a variable that says task sequencing is okay to proceed. It's not a super peer. Not a super peer is true. And then on the imaging, I say not a super peer is true. So if we detect that this is a super peer, we never set this variable to okay to proceed, and then the imaging section will never run. We'll just bail out of this task sequence and protect the super peer from actually getting the deployment run on it, or the task sequence run on it, right? So be aware of that. So that's imaging a system to seed the content, right? Whether you use the download content in advance option on the deployment, or whether you use the way to just set it as a required deployment, and then we grab the content from within a task sequence and don't really need the download package content step, or you use a combination of the two, doesn't really matter. That's how we can set things up to get the content into your super peer. Okay, so now I want to walk through a series of examples that kind of show you different options, all kind of being put together to lead toward understanding of how these different options play, when they're necessary, how to use them, etc. Right? So we're going to deploy some systems using Pure Cache. And so this method to deploy systems using Pure Cache with the task sequence supports bare metal imaging of known and unknown computers, no problem. You can use upgrade task sequences, right? No problem there either. We're going to use unknown computers in this demo, and the first task sequence I want to show you is this one, okay? So I'm going to edit this one. And so a question may come in, and I didn't really see good guidance in the documentation on this. Where do we actually use, if we're going to, the download package content step, okay? So here we're going to immediately, as soon as the task sequence starts, step number 2 in the task sequence is we're going to download content. We're going to say that it's going to be stored in the task sequence working directory, because it's going to be in Windows PE at that time, because I'm starting it in bare metal. Right? Really, I probably should have put it under restart in PE to be sure, but either way, it's going to be in Windows PE for this. And one of the things I did, so on my collection variables, I set this SMSTS preserve content to true. Okay, meaning it's a flag to tell the system once you download the content, keep it in the client cache. Here, I'm setting it to false, right? So I'm overriding the collection variable by setting this to false. Okay, and the content, we'll see what happens to it. Okay, so the download package content step, again, I'm going to download 4 items. Now, the interesting thing about this is the task sequence itself only requires 3 pieces of content. We need the image right here. Right here. We need the ConfigMgr client, and we need the application rich copy. So we'll see what happens whenever we get through with this. So the question is, what will happen in a couple of scenarios? What will happen specifically to the application content? Will it be kept in the cache? And what will happen to all of the content based on setting that variable to false, don't preserve the content? So to test that scenario, let me pull in my first imaging system, and that'll be this one. Okay. And so I'm at the screen to go forward, and I'm just going to click next. Interesting. So I'm going to have to reboot this one, apparently. Let me try it again. Pause real quick, and we'll get back to that screen. Okay, let's try that again. So click next. Failed to run task sequences. Interesting. I will, something must be going on. Let me fix that, and I will be back to it. Okay, I think I realized what it was. I had, as you might expect, been using this to test and get ready for recording the session, and I had failed to delete the systems that had imaged already using this approach I'm going to show you from my ConfigMgr environment. So let's see. Okay, much better. So I went and deleted those when I paused the video, and so we'll just kick off this first task sequence. All right, let me pop open a command window, and so you see that we're running the download package content. So I'm going to move to the folder with the log. And in just a minute, whenever it starts actually downloading content, we'll look and see what's happening. Okay. So waiting. Pause the video real quick, and we'll wait for the step to start downloading content. Okay, so it's downloading package content. Let me go ahead and open the log now. And good enough, move that down to the screen. And so just want to show you that we are downloading content, and we are going to get it from our peer. So right here, basically we can scroll through the log and see it, but you can see right here that we're actually using our branch cache enabled system. Here's another example of it. Here's another example of it to retrieve the content. It's not that we don't know about the distribution point. We do. CMSA1. Let's search up for it. We do, in fact, know about our traditional DP. We're just not using it because we have the content available on our peer cache. And you can also see, actually C's, let's see, is it there? Yeah, but it's not there, D. So you can see that we're actually storing the content here. So we're downloading the content here. It's coming in, no problem. Right? So what I'm going to do now through the magic of virtual machines is fast forward this to the state of this machine after imaging complete. So let me go ahead and apply a checkpoint to this machine. I'm going to pause the video while I do it, and I'll be right back. Okay, so just applied the checkpoint, and now the system is coming back up. And so this is what the machine looks like when the imaging is complete. So let's go into this machine, and I want to show you a couple of things. First, one of the last things to install is rich copy. So rich copy did install. It's here. So let's look and see what happened, because we saw that download package content was actually trying to download 4 things. But if we look on this PC and look at the CCM cache, we'll see, in fact, that we have only 2 things. Well, that's odd, because I said to not preserve any content, so one might have thought maybe there would not be anything here. But there's 2 items here. What 2 items? Well, one of them is the rich copy application, and the other one is CCM setup, right? Well, both of those actions happened in the running OS. And so nothing was preserved from the Windows PE phase. It was downloaded as part of the running OS, just traditional ConfigMgr client operation. And so not a huge surprise that it's sitting here in CCM cache because the client downloaded it as a part of completing the task sequence once we are in a running OS. And one other thing I want to show you while we're here, if we go into WebMTest on this system, just to show you, we have this enabled to use a pure cache from the command line or the task sequence variable to set that, but that does not turn it on as a that does not turn the system on to itself become a super peer. So machine policy actual config, right? So if we just go in and look at that class, you'll see that it's not turned on itself to be a super peer. There would have to be some other way that we enable that. So I look at instances here and then show them off. Can be a super peer is set to false because it is not in a collection that would in fact enable it to be a super peer. All right, so let's get rid of all that and get rid of that machine. So that is the first demo. Now, I want to show you, let me go back in to my software library. And now there's actually task sequence 2. And I want to show you this one. It's set up very similarly, right? So here, very, very similarly, the very first step is to download the package content. What I have not done here is supersede the setting of SMSTS preserved content. So SMSTS preserved content is going to still be set to true, which would tell the task sequence, hey, go ahead and preserve the content. But same conditions as before, the task sequence itself only needs 3 pieces of content. This one, the image, this one, the ConfigMgr, this one, the ConfigMgr client, and then this one, rich copy app itself. So let's go ahead and run this and see what will happen here. So let me pull in another machine to run task sequence 2, and that's over here. So if I click next, go ahead and run it, click next. Okay, so we will kick off task sequence 2. And so we'll do the same thing. We're just going to go ahead and let the content be downloaded. We'll confirm that it is. So like before, we'll let this start to download the content, and we'll just check the log real quick. Be right back. Oh, there we go. Just as quick as that, it's starting to download the content. Good enough. So let's pull up the log. And so we see, in fact, it's downloading it from our peer cache enabled super peer, right? And so, again, through the magic of checkpoints and virtual machines, I'm going to go ahead and bring this forward to after the task sequence completes. So let me go ahead and apply that checkpoint, and I'll be right back. And the system is coming back up after applying the checkpoint. And so let's see what happened to it. So we'll log into it. And what I want to do again is show rich copy. One of the last things to happen during the deployment is here, right? And so let's go look at the CCM cache folder. And so this is, we've already seen this with the SMSTS preserved content set to false. Will there be any difference here? If I look at CCM cache, we see 4 items, okay? So now, what 4 items are they? Well, here's rich copy, okay? Here's CCM setup, and here's an install.wim, and here is CCM setup again. Well, so that's interesting, right? Let me pull up, I'm going to pull this out momentarily, and we'll just look for a minute. So look at this download package content, and we'll compare this, right? So there, see if I can get these side by side. So one is batch test. Here's a boot image. Here's an image itself, and here's the ConfigMgr client, right? So this image is actually not the one being deployed by this task sequence. This task sequence is deploying an 1803 image. If you look, so here's the 4. So if you look at apply operating system, it's deploying one called 1803. That is not defined here. Also, you see bat test is defined here. So it's not, neither one of those are actually here in this 4 items that are listed. So why are there 4 items here? Well, all of it has to do with the fact that the two things, SMSTS preserved content is enabled here, and this download package content is positioned prior to the disk formats. So we did in fact download all 4 of these, but then we formatted the disk and wiped all 4 of them out. But then we downloaded the OS again here and applied it. We downloaded the ConfigMgr client here and applied it. We downloaded rich copy here and applied it, right? So we kept all 4 of these because they were actually downloaded as part of the OS deployment after formatting. So we did in fact keep 4 of them because of that SMSTS preserved content, but we did not keep this one because it was not needed by the task sequence, and we did not keep this one because it was not needed by the task sequence, right? It was just downloaded here without being necessary, right? Okay, so and also that same system, I can show you, but I won't make you sit through it here. I've already closed it. Is not a super peer, right? The only thing that's different between this task sequence and the last is I have allowed SMSTS preserved content to stay true. So what's the conclusion? 1, the positioning of the download package content, if you're going to use it, is impactful. And 2, the result that you see is absolutely expected based on the fact SMSTS preserved content is there and is set to true. Okay? Now, so let's continue. So what about this next one? So what is the difference here? So if we go into properties or go to edit this one, here we're going to see that the download package content has been repositioned. Same 4 things as the previous 2, but now it's different. Again, the task sequence itself requires 3 items. One of them actually, one of them is not, actually 2 of them will be in addition to what's downloaded by this step, right? So what will it be? There's actually an additional piece that will come down from CCM client being downloaded or ConfigMgr client being downloaded. There's also this apply Windows settings or apply operating system step will download an additional image because it's not defined here. So let's also this one, so we repositioned it, but it's still configured to download the content into the task sequence working directory. So this one is same as before. The SMSTS preserved content is enabled to true, and the SMSTS peer cache to allow it to retrieve content from a peer is also set to true. So what we want to do now is initiate this task sequence and see what happens. So let's pull in another machine and start it off. Okay, and this time we'll choose task sequence 3. Make sure I'm choosing the right one. Here's that one. All right, so now it's partitioning the disk. First and foremost and straight away, we're getting the disk partitioned. And so we'll pause the video, wait for the content download stage to happen, and then we'll come check it out and see what's happening. So we're to the download package content step. I'm going to enable the command prompt. There we go, some of it downloaded. So let's open up the task sequence log. We see that in fact it is downloading the content. You can see that it's, well, let me position this better. Scroll it down. So you can see in fact we're getting it from branch cache. We're referencing the peer cache. So I said branch cache. That's because this says branch cache. But we're leveraging from peer cache. And that's a point too. So this does say branch cache. Don't be confused by that. This is actually using peer cache. I don't have branch cache turned on in this environment. You can see that it's using the peer cache to get the content, right? So we're going to let this thing complete. So again, through the magic of virtual machines and checkpoints, I'm going to go ahead and fast forward this thing to after the image completes, and we'll take a look. Okay, so let's log in and take a look at it. So here, if we go into the folder where the client's installed and go to CCM cache. So now we see 6 pieces of content. Why do we see 6? Well, so again, we repositioned the download package content step so that it happened after the format, so we had the opportunity to preserve all of the content that was downloaded as part of that step, right? And then we had some additional content that was needed by the task sequence that was not defined in the download package content step, so we downloaded that in addition. So let's look through. So here is rich copy, which was the application, the last thing to install as part of the task sequence. Here is the CCM setup directory downloaded. Here's a boot image that was specified as part of it. I'll show you it in just a minute to compare. Here's one install.wim, right? I say one because there will be a second one. Here's the batch file download that I included in the download package content. And here's our second install.wim. Why do we have two install.wims? Because the one defined, let me see if I can parallel these a bit. Yeah. So here's come on. Here's six, well, sorry, if I can get the windows right. There we go. So here's 6 that are on the client. Here's 4 that are in the download package content step. This image is not the one I'm deploying at all. Here's the batch test that I downloaded, but I didn't use as part of the task sequence. In addition, I did apply a different operating system, so we downloaded that. And then as part of downloading Setup Windows and ConfigMgr, we had some additional stuff related to the ConfigMgr client that we downloaded, right? So this all makes sense. So conclusions from this: the positioning of the download package content step is very, very impactful. What you're seeing is absolutely expected based on the fact the SMSTS preserved content flag is there. And also notice what happened here. We did not just get content preserved that was defined by the download content or download package content step. We got all of the content preserved that happened after the format whenever we have that SMSTS preserved content flag set. Right? Okay. And also, this system is not enabled as a content source peer. Let me just show you that one for continuity. Pull back in that machine that I just closed out of, and we'll just quickly pop in the WMI. So again, nothing different on this one. We're still using the same 2 variables, and so nothing that I've done special to enable this as a content source peer, so it won't be. Policy, machine, actual config. Okay. So if I just did in classes, look down at that class that I told you about, CCM _ super peer client config, instances, here we go, show moth. This is not enabled as a super peer, right? Okay, so as expected. So we'll just pull that one out, close it down, and if I can click correctly, move on. Okay, so now that's task sequence 1, 2, and 3. What about task sequence 4? Okay, so what did we do differently here? Same exact concept. The only difference is that I've now moved the download package content as the last step in the task sequence. And so there's a lot of content that was downloaded prior to this. Then I defined a few more, and this time I'm telling it to store in the ConfigMgr client cache because now I'm in the running OS. And so the question is, will the content defined in the download package content step that has been downloaded already be downloaded again? Because there's certain things that have been downloaded already. There's specifically this package is the only one. Package ID SAP 00003 is actually already downloaded as a part of the step. So we know what to expect, right? The content's going to be preserved. The question is it a duplicative effort to re-download the content based on something being defined here that's already actually been downloaded? So let's test that out. So we're going to just go ahead and start the image deployment. And I'm not going to show you this stuff coming from the content source peer yet because the download package content is at the end and the steps that will download the content are at the end. So I'm just going to go ahead, or well into the task sequence. So I'm just going to go ahead and pause this and apply our snapshot checkpoint, and then we'll see. Okay, so the snapshot or the checkpoint is applied. We're coming back up, and let's go in here and take a look. All right, so the question on the table is, will our content re-download? So pretty easily, I'm just going to go in here and search for start executing. And that will help me hone in on the specific part where we're downloading content. So will be the last thing we do, but here we go. Download package content. So basically what you'll see here is what I want to show you is that we check, let's see, where is it? We do check in the cache to see if it's there before we actually start to download. So location reply, content location request. Let's see. I'll probably find one here in a minute. Let me find it in here and I'll show it to you. Hang on a sec. So it's in this section where you can actually trace it by content ID and see that it's actually checking, just like CAS would. Is it in the cache? If not, I've got to go get it from my distribution point and so on. So the answer is, and the question that was on the table, will the content be downloaded twice? It should not be. It may be if there's something wrong with the content, or it's detects that we need something, we didn't get the full content, whatever. It could download twice, but it should not be if we get that content downloaded correctly the first time. Now, so the last one I'm going to demo is this one. And so the difference here is I do not have any download package content steps here at all, right? So the question on the table, is the content preserved that's downloaded as part of the task sequence, even if you don't have the download package content step? Because we do have the variables coming from the collection. SMSTS preserved content is set to true, and we're set to be able to use pure cache, right? So let's actually run the last task sequence demo and choose task sequence 5. And here we go. And so we don't have any download package content, so I'm just going to let this proceed like I did the other one. And the content actually gets downloaded about halfway into the task sequence. So through the magic of checkpoints, I'm going to apply what it will be after the image complete. And so the checkpoint is applying. And so what I want to show you when I log into this is the status of the CCM cache folder. So if I'll look at the CCM cache folder. All right, here, I do in fact see 4 pieces of content, right? These are all the pieces of content that were needed as a part of running the task sequence. There was nothing else downloaded besides what's in the task sequence, but everything that was needed by the task sequence whenever it ran is in the cache. It is held by the cache, whether that content was downloaded in the running OS, whether it was downloaded as part of Windows PE, it makes no difference. So the conclusion here is that the download task sequence step, it's absolutely a convenience if you want to use it, but it is absolutely not a requirement to persist content in the cache. The download, the download package content is there to complement the pre-download option that's part of the deployment. And you can do other things with it too. Just be aware that it's not required. The SMSTS preserved content variable is absolutely the key to preserving content in the client cache. And just a reminder, our discussion around preserving content in the cache assumes that we want the imaged system itself to become a superpeer. If you don't want that to be the case, then persistence of content in the client cache doesn't matter. You don't even need to use the SMSTS preserved content flag, right? Okay, so there's one other task sequence I want to show you, and I'm not actually going to demo it, but I just want to show you. So I keep talking about the idea of enabling an image system to become a superpeer if you want to. So consider a situation where you image a system. And then one of the last things that you might want to do is set this to be a superpeer. So that could be very simply that you just run a quick script to enable this thing to be a superpeer. Now in this case I just put some placeholders here, I didn't write the script. But very easily you could actually add this client as it finishes imaging to your superpeer collection. It then becomes a superpeer because it gets the client settings to turn that on, and it has all the content loaded into its cache already by using a combination of what you've seen already, right, to get that done. And now that system totally becomes a superpeer. All right, so those are the task sequence demos I want to talk about. Now, a couple of other things. We've walked through these task sequences, and I've shown you, in several cases at least, what it looks like in the SMSTS log where we are actually pulling content from a content source peer, a superpeer, instead of a traditional DP. So let me show you what it looks like when that request is made. So I have my management point on my site server, and I've actually reset one of the VMs, the first one, and I'm going to start through the task sequence again, right? And so this time it's going to go into the process of pulling content. So I'll just let that do its thing a bit, and I'll pull this out temporarily. And so specifically, what happens whenever the imaging system is going and requesting content is it will be talking to the management point. There's a log on the management point. This is the name of it, but just to show it to you, there's the logs for the management point, and also shared with the client. But here's the location log. And so if I open up the log, let me just pause for a minute because I'm just now starting to actually get content. It looks like, so the first one I just saw go on my other screen. Looks like another one is getting ready. So pausing just for a minute on that. Well, okay, so there it goes. So we see, so what happens is we'll send up a location request to the management point, just like we do for any other type of content. And so let's scroll to the bottom, right? And so what happens is we will run a couple of different stored procedures. So this is just in the middle of a content location request. Here's the stored procedure that we've always run to get the distribution point locations for a given piece of content. So MP get content DP info protected. There's also a get DP info unprotected, but then there's this one, and this one's new. So MP underscore get super peer content locations. So this is just a stored procedure in SQL that we run. There's logic in that stored procedure that will tell us what's going on specifically. And when we get the result from both, we put them together, and that's what we return to the client and flag super peers accordingly, right? So if I were to go into, I'll do it just to show, go into the database and look at the section where we have our stored procedures, then we could actually get into the stored procedure and look at it. There was actually a situation in 1802 where things weren't coming back exactly as they should in certain cases. So if you tried peer caching in 1802 and it didn't work for you exactly as you thought it should, give it another try, because that bug with that stored procedure is fixed in 1806. And it does work the way described in the content source priority selection that I showed you earlier. So it didn't mean to expand tables. Nope. Instead, I wanted to expand programmability. I don't know why I can't say that. Stored procedures, and then there's the MP stored procedures. So let's just scroll on down to those. MP, and so then the one we're looking for is get super peer. So scroll on down, get super peer content locations right here. So if I want to go look at it, I can look at the definition of it, scroll through it. We'll see exactly what we're looking for and could decipher from there, right? This is something you won't generally have to do. Actually, if you're doing it at all, you should be working with support, but it is there for information. Another thing we talked about in session 1, not really something I've shown you here or will show you here, but the process by which the clients will tell the site that they now have content that they can serve for others. Say it a different way. We talked a lot in this session about seeding content onto the super peer. There's a process by which the super peers will actually notify the site that they have content they can start to share with others. That process is by sending state messages. So as the content gets added to the queue, then we'll send up state messages at that time to say that the content is in the queue and can be used to serve to others. I can show you that on the super peers that are in my lab, the super peer that's in my lab. The imaging systems are not yet super peers, right? You can add the logic to make them super peers, and so there's not going to be any notification back and forth about them being able to serve content to others yet, because they can't, right? But let me just show you real quickly, and I went more into depth on it in session 1, but let me just show you here. So let me pull back in my Windows 7 SuperPeer, and all I'm going to do here is remove the content from the cache, and that's going to trigger a series of notification state messages back to the site to, in this case, let the site know that in fact it no longer has the content, right? So here I'm just going to delete my files, say yes, and it's going to do that, get rid of them from the queue. All right, and then there's a bit of content there, so it takes just a second. But as soon as it's done, we'll go check and look at the state message situation. So it just finished. So let me get rid of that, and we'll go find the state message log. All right, so CCM logs, so state message. And so the last entries in the log should be about sending out these state messages, and you do see them. So remove this content, remove that content, remove the other content. So this is just sending notifications up very quickly to the site to say, I can no longer serve this content, right? So whenever we were to add the content, it would say, it would do the same thing, but it would be an add state message that would instead tell the site that it does have the content, right? Okay, so a little bit more detail about that in session 1. And so one other thing I'll show you in terms of tracking all of this. So we do have some reports that will help you understand what kind of success you're getting in terms of pulling content from peers. So if you search for peer, you'll see 3 reports that will show you rejection or details about rejection or whatever, right? Okay. So let's move the site back out. Okay, so in terms of starting to wrap up now, some tips and tricks a little bit. I've already shown you most of these things, right? So in terms of the logs, we have client logs. And specifically for OSD, we have the SMSTS log. You'll be able to see that the imaging machine is being serviced by a peer if you notice in the URL, the SCCM_branch cache $. That's an indicator. Besides the system name that it's pulling from, it's the system name plus that the SCCM_branch cache $, that will tell you that in fact a peer is being used versus a distribution point. From there, there are kind of the standard lookup kind of entries you would expect out of the CAS log, content transfer manager log, data transfer service. In the case of imaging, all of those entries are in the SMSTS log. Right, so you can look there. I showed you the management point, the MP_ location, and specifically focusing in on the stored procedure related to peers, retrieving peers that have content, MP_ get super peer content locations. In WMI, there's actually 2 entries. I've shown you one. The one on the client that allows you to confirm that you in fact are configured as a super peer is the CCM_super peer client config namespace under the actual config in WMI on the client. There's also one on the site server. Let me show you this real quick. So if I go into WMI on the site server, and I'm just going to show you this. You can look this up if you want to know more about it. But if I connect up to root SMS site_SAP, name classes in recursive and all, and then I scroll all the way down near the bottom, there's going to be this class called Windows PE Peer Cache Config, right? And I don't have anything configured here, but in this class, actually, let me just show you a little bit of detail here. So I just quickly pulled it up in our documentation to show it to you. So basically, here, right, if I want to search for this. Okay, so this is just a class that actually works to input settings onto devices to basically say when that device will reject requests for content, right? So if you have a system that is in low battery mode or processor load exceeds 80% or the rest of these things, then that client will reject any request for serving others because it's kind of in a compromised state itself, and you don't want to get halfway through and have the battery die or just be slow because the processor is slow or the disk is slow and whatever, right? So if you want to look in the documentation, you can see that there a little bit more. And so let me pull the site back out. Right, and so that really wraps up, what I wanted to show you about how this whole thing works, pure caching specifically for OSD. Split it out into its own session because there are some of these different things we need to understand specifically in an OSD environment. Hope this all made sense. So we will see you next time for session 3, where we'll talk about branch cache.